Hello, this is Junichiro Horikawa, and today I'm going to use a Rhino 7 beta. That is together with the Grasshopper, and that is because I wanted to try out this new feature for Rhino 7, which is called SubD, which you can create a subdivision geometry from a mesh, then you can convert it into B-rep as a smooth surface. And I have tried out making this kind of soft body chair or sofa from a mesh and convert it into B-rep with this smoothness, and with some parameters you can control, like the depth of the chair and the resolutions where you want to create this hole. Also, you can control the curvature for this hole pretty easily, like a mesh, but actually you can have it as a SubD mesh, SubD geometry, meaning you can easily convert it into B-rep, so it is production friendly, real production friendly. Alright, so the possibility of SubD is really vast, and if you know how you can optimize or how you can modify mesh geometries, then you can easily create this SubD mesh. So this is what I'm going to show you as an example, how you can control the mesh geometry and then convert it into SubD. Right, so let's do this from scratch. What I want to create is a soft body software, so I'm going to start by creating a sphere mesh. Right, so I'm going to go to the mesh tab and then use some sphere based geometry from a primitive. I think I can use this one, mesh sphere X, which can create this kind of mesh geometry with the clean edges, kind of a subdivided square, subdivided box with sphere outlook. Okay, and let's have some parameters to control the subdivideness of this resolution of this sphere, to have an integer value to this C value, C input. Okay, like this, right? And then let's also create a equivalent sphere surface, which I'm going to use it in order to get the point position using a UV, because this is a mesh, you cannot define a position by UV. So I'm going to create equivalent sized sphere. So I'm going to create two sphere the same size, one with the mesh, one with the sphere. And for the sphere surface, I am going to use a evaluate surface in order to pick up one of the point using this UV value. Okay, and to do that, I am going to use a MD slider. And also, let's reparameterize this surface so that I can use a UV in between 0 to 1. Okay, so this is currently the picked up point. If I move this slider, I should be able to define any place in the surface. Okay, maybe I can use this slider around right here. Okay. Now, what I want to do now is to push the point which is around this point inward to create some kind of or cleats or hole where people can sit inside. to do that, I am going to create another sphere based using this point that I found down on the sphere as the center of new sphere. So I'm going to create a new sphere using this P as a new center, and then set some radius for this new sphere, which is going to be the size of the hole. Let's say 20 something. Maybe that's too big. Let's set the maximum to 20. Like this. And I'm going to use this sphere as a power field to push the points inside this sphere. In this case, the point is this vertices for this mesh. I would like to move the vertices which is in this mesh, which is belong to this mesh, inside this sphere to a inward direction. Alright, and let's also define the direction where which direction I want to move the point to. I guess what I could use is to use the normal vector that I found on the original sphere at this point. So maybe I can use this n normal direction as a moving direction, and normally the normal direction goes outward, so I can create a negative value for this normal so that it goes inward. Right, now it's time to get the vertices information from this mesh. I can deconstruct the mesh. Alright, and then look into the point inside, look into the vertices inside this power field sphere. So I can use a point in brep, and the brep is the sphere, the point is this one. Maybe I can use the graph at this time. Oops, not the graph. Okay. So check the point, whether the point is inside the sphere one by one. Right. As a result, I should be able to get either true or false. If it's false, that is the point is not inside, but the truth. If it's true, then the point is inside. So I just want to move the point which is inside the sphere, which is in this one. Right, so let's do that. How can I do that? And how much I want to move depends on the size of this sphere, I think. So first I can retrieve the point position, right, which is this one, and then maybe create a line starting from all those points, or just the point, well, yeah, with all those points, then using this normal direction as the direction where I want to move. So currently all those points are going inward like this, including the points that is outside that. But by setting the lengths based on the inward or outward, I can control the lengths, I think. So let's do that. And for those values, for those points which is inside this basic power field sphere, I want to create a really long line so that this line can be intersected with this sphere. So let's create some long lengths, like say panel, or maybe I can use some values based on this one. So maybe I can multiply this sphere radius by 2. That should be long enough in order to create an intersection. And also multiply this by this true or false, which can be converted into 0, 1. False will become 0, true will become 1. So if it's false, then the length will be 0, so you just get 0 length line. So let's have that on third input for the multiply, then have it as a length. Now you have a bunch of lines, and all those lines coming from those points outside the power field has length of 0, so you don't see any lines. Okay, now it's the time to get an intersection between this sphere and those lines. So vrep curve, vrep curve, vrep is the sphere, curve will be this line. Alright, now I have a bunch of intersected points. Now what I could do is directly, maybe I can try changing the position of the vertices into a intersected points, which in this case when the intersection has been found, there is a output, and if there's no intersection found, there's no points on the list. So first I could dispatch the list of points using this true or false, inward, inside, or outside pattern, and then combine the outward point, which one is it? So this is the inward point, this is the outside point. Right, so by combining it and then make it flatten again, then reconstruct the mesh from those vertices using construct mesh with the face information that we have just got from the deconstruct mesh. Like this, I should be able to create a new mesh with a new vertex information. Right, let's try to create a SubD geometry out of this mesh to see how it looks like. So I can do what I can use is this SubD from mesh, which is only available from Rhino 7. And if I connect it, it is going to be converted into a SubD geometry, and then you can also convert it into vrep after that to make it can be used as a vrep geometry. And let's try to preview it with some colors to see how it looks like. Now, as you can see, there is a bit of problem with this geometry because the edge of this geometry doesn't look really clean, like right here, like here, and so on. That is because I have directly moved the point to the intersected points, but to make it smooth I have to have some kind of a damper functions in order to make it smooth based on the distance. How much it moves depend on the size of this power field sphere, right? So let's think about it a bit more logically. First of all, these are the points, right? And then if those points which is inside this sphere is closer to this power field sphere, then I don't want to move those points that much. Maybe I want to move those points which is close to this sphere in terms of distance really small. But if it's inside if it's close to the center of the sphere, maybe I can move the point rather far or rather strongly. So based on the distance, the closest distance from those points inside the sphere to the edge of the sphere, maybe I can control how much the movement affects, like gravity. Right, so to do that, let's first calculate the smallest or closest distance between those points to this sphere using closest brep closest distance, right? And then connect brep to the B, connect point to the P. Now as a result, from a output D you can get a distance, a closest distance from point to a brep. Now I can use this in order to convert it into a force multiplier, how much the point should move to inward. Right, now let's just retrieve the points which is inside the sphere by using the dispatch with this parameter. Okay, so the value out of inside the A is the actual value that I want to use, which is inside the point, which is inside the sphere. Now let's flatten this value first, and then get the bound, meaning get the range from minimum to maximum. Currently the minimum distance is 0.0004, and the maximum is 10 point something. Right, and I can use that together with the remap numbers to remap the distance to a range in between 0 to 1. So currently I am having a value in between 0 to 1. Now then I can convert this value to using a graph mapper to remap it using a different kind of curves, like sine wave like curve, like this, in order to change based on a distance and this curve. Alright, now the range is still in between 0 to 1, so after this I can remap this again, or maybe I can leave it as it is for now. And what I can do next is to unflatten with the original value coming from this A to make the data tree come back before flattening it like this. Now I can use it with those values which has similar data type. Okay, so where I can use that, what I can do is to use a vector in order to move the points from the original point to inward. So first I'm going to create a vector 2, and the original point position is actually this one. This A is the value, the vertices which is inside the parafield sphere, right? And that's the original position to create a vector from. And this P is the goal of the vector point that should move to. Right? Now that I have a vector from the point to inward, what I would like to do is to use multiply with this value that I've created using the distance. So the closer the distance is, I want to multiply less value to this vector. So closer the distance is, closer those points are to this sphere, then I want to move less to inward. if it's father, then I want to move father. So I can do that by multiplying it together. Alright, I cannot really see what happens by looking at the numbers. Let's see visually by using this as a moving vector. So I'm going to use it to t. Then what I want to move is this value a. Okay, now the point has been moved inward. Let's hide out all those stuff. And instead of having the points which coming from the intersected points, I'm going to replace it with this moved point. And as a result, you'll be able to create much more smoother values, much more smoother shapes like this. All right, and currently I still have some ugly edge, kinky edge right here. So let's try to control the resolutions to see if I can remove that. So if I set it to 4 or 5, looks better. 7, 8 might be better. Maybe set to 5. Looks better. All those edges become smoother. Looks nicer. Alright. Now everything is already almost done. I think what you can do now is to set some parameters to see which parameter looks better on for the geometry, the output geometry. Okay, so let's create it. So this is the size of the per field sphere. I can control the depths of the hole by controlling the position of this MD slices. I can change the position of the hole like this, and then by changing the curve shape of this graph mapper, I can change the shape of the hole. And because I'm using the distance value as a multiplier here for the vector, all the results become really smooth and looks really good. All right, nice. And what's good about using SubD is that the result value, the result geometry you get is brep, so you can use it like for analysis pretty easily compared to meshes. You can have really smooth surface for the production. There are many benefits using SubD instead of mesh. Right, so that's pretty much it. A simple way to modify the mesh and convert it into SubD so that you can use it as a brep afterward. You can also just bake this as a SubD itself and control the controlling points for the SubD like this as well. And this is still can be converted into brep as well. Right, so it's pretty, the SubD is pretty powerful. Yeah, I cannot wait for the Rhino 7 official version of Rhino 7 to come out. Okay, so that's it. Thank you.